Chapter 9 about preserving species one by one by one. Chapter 10 about preserving entire ecosystems, and kind of the opposite too by looking at the damage that's happening to entire ecosystems. And then chapter 11 is very similar but underwater. It's about aquatic ecosystem and maintaining them in a functioning state. Okay? So in these older PowerPoints, they each stop with some big ideas. And the great things about these kinds of overview questions is that they point out some of the main topics that you should have, that you should understand when you're getting ready for the test. I will point out that when we take the test, which I'm maybe next week, but maybe the week after, probably not next week, but we'll try. When we take the test, I would say 80 to 90% of the exams are based on the textbook, and most of the questions are written by the authors of the textbook. So you guys that are caught up with your reading should be well ahead of the game already. And you should use these overview questions as tools to guide your studying. No, I don't think you should write all these down right now, but you should look at them and see that they're kind of major topics. Human activities and biodiversity, forest resources, tropical deforestation, rangeland resources. You could almost turn this into an outline of the chapter, the major topics. Parks would be the next one. Nature reserves, wilderness, ecological restoration, and actions that we can take. So you see how I kind of reduced each of these to a single topic, right? So these are questions about those major topics. And when you look at your textbook is organized more effectively, I think, than the old textbook that this PowerPoint came from. And in yours, it's really clear. It's like section 1, tropical deforestation or whatever it is. Okay, so I think we've talked about the wolf a little bit before. It's a really interesting case study. And I will point out this phrase, case study, is when you use an example to illustrate a point. You could use other examples. And when it comes to getting ready for the big AP exam, you should have a bunch of case studies in the back of your mind. I think of them as like a toolkit. You know, the carpenter, the electrician, the plumber shows up to do a job, and they have a whole bunch of tools with them. Are they going to use every tool, every job? No, but they might need it, huh? So they bring it with them. And the same thing is true of these examples and case studies. You might get asked a question where the story of the wolf is relevant, and you could use that as part of your as part of the whole thing that you do when you're like doing one of the FRQs, for example. But then again, maybe that one won't be relevant. So you need to have a whole toolkit of these case studies ready to go. So the wolf is an endangered species, although there's argument about whether it should be endangered or threatened. And this again is in the contiguous U.S. in the lower 48. It is not a protected species in Alaska because their population is pretty big. So you can see lots of wolves were killed in the end of the 19th century, but it turned out that they're a keystone species. In other words, they kind of hold the ecosystem together. And so in the 80s, there was a movement to return them to Yellowstone. Okay? I'm probably not going to give you guys time to write everything down because I want to do the whole PowerPoint in one day. But you have access to it, right? It should be in files and then under sustaining biodiversity, unit 5. And if it's not, then I can take care of it. So didn't we look at this picture already of before and after wolves? And in particular, before, I guess, was after they were killed, but before they were returned, right? And here we have all these elk coming down to the stream banks, and they're eating up all the streamside vegetation. Makes it harder for songbirds. It makes it harder for cold water fish because the water gets warmer without the shade. And basically, Yellowstone was like this from the early 1900s almost to 2000. And at the same time, the coyote numbers increased because they didn't have to compete with the wolves. The coyotes are a little different predator. They tended to eat the smaller prey and leave the elk alone. So the elk's numbers grew beyond the carrying capacity. Then when the wolves were returned to Yellowstone, now the elk, they don't go down to the creek very much anymore because only to drink, but they don't like hang out down there because there's too many hiding places for the wolves. Once the elk population dropped, I should say, the streamside vegetation came back, giving the wolves hiding places. Also, the beaver were able to return. Coyote numbers dropped. And the songbirds increased because now they had all of this habitat along the streams and so forth. It's kind of amazing. I've even seen a thing about how the physical characteristics of the streams changed as a result of returning the wolf. And I think specifically the temperature got colder, but the way the stream flowed may have changed as well. So that's one way to look at it. Another way is on this graphic. And I'm going to zoom in on these different parts. But so in the 1920s, we exterminated the Yellowstone wolf, but in 1995, we brought it back. And this put the elk populations back under control again. So you can see there's a little arrowhead next to where it says elk populations. It's pointing down. So keep an eye on that. Like here, we see that the wolf population went up in 95, down in the 20s. So keep an eye on the ups and the downs in this diagram. Elk populations went down after the wolf came back. Turned out that was a good thing because they were overpopulated for their environment. Beaver population also went down. And these creatures went back up. So it's kind of a chain reaction, isn't it? Where one change in one part of the ecosystem led to these changes in other parts as well. Some scavengers dropped, but overall the biodiversity has gone up. It's not that ravens and bears and eagles are gone, it's just that their numbers are a little more in balance with the ecosystem. And coyotes have gone down. And that has allowed these guys to go back up, foxes and antelopes and voles. Voles are little rodents. So the big idea here is that the wolf plays an important role in its environment, huh? And by killing off the wolf, we thought that we were doing something good in terms of, oh, there's going to be more game for us to hunt. There's more elk for us to hunt. Also, it was partly driven by farmers not wanting to lose their livestock to the wolf. But we can see that it really put the ecosystem out of balance. And those big changes that have happened since then really demonstrate that. Of course, the ranchers are still not very happy with the wolf being there because wolves are going to kill calves or sheep or whatever kind of animals they're raising. And so there are groups that have collected money to pay the ranchers if they can prove that they lost an animal to a wolf, then they can get reimbursed for that loss. Okay, more details about that whole story, but I want to get on to the big picture. So, why should we care about biodiversity? Well, we can split these reasons for caring into two groups: the usefulness of the organism, or other aspects of the organism that don't have to do with its use to people. So, is it useful to have it for our economy or for the ecological services that it provides? Kind of a different category than things like what is the right of the organism to exist? Um, what are the rights of future generations to be able to see that creature? Aesthetics has to do with what we find beautiful, although that wouldn't have to be physical beauty. It could be intellectually stimulating, I think would fit into aesthetics as well. Okay, a couple big ideas in this section on forests, so read through those. So the ecological services provided by an intact forest, although hard to quantify and often not really quantified or measured, they can be greater than the value of the raw materials that we could get. So the value of the logs from cutting down the forest is often less than just leaving the forest alone and letting it, for example, continue to clean the water. Water purification happens as the water moves through soils. And leaving the forest intact continues that ecological service. Reasons for unsustainable cutting include, excuse me, chief threats to the forest include unsustainable cutting and burning and outbreaks of diseases and insects. And then we have this issue specifically of tropical deforestation that we're going to look at. And the tropical forests have even greater value intact because the ecological services they provide are irreplaceable. So here's a list of ecological versus economic services. And you should get these ideas separate in your mind. They're both providing value to people, right? But the economic services are the ones that are specifically about jobs and resources that we can use, right? The ecological ones are the ones people forget about. Intact forests do all of these things on the left, but they're hard to put a dollar value on, which is why it says it's estimated at $4.7 trillion per year. It's hard to measure the value of that. And these ecological services are partly for us and partly for the environment as a whole. I'll give you one example here. Maybe I've talked about this before. Purifying water. As the water goes through the soil, it gets purified. And some years ago, New York City needed a new water supply. And they had to choose between building a new water purification plant, or somebody said, well, why don't we just protect the forest And so they bought all this land upstream from them where the forest would purify the water for them. And that turns out to have been very effective and less expensive than building the new water treatment plant would have cost. At the same time, they gain all these other services that they wouldn't have had if that forest had been cut down. I think the big idea here, I'll just say that I have seen test questions, maybe in this chapter, maybe in others, where they ask you, which of the following is not an economic service of forests? And it lists these like 5 choices. 4 of the 5 come from this column. The one that's not an economic service comes from this column. Are they all services provided to us? Yes. But the question is really asking, can you tell the difference between an economic and an ecological service? See what I'm driving at there? Okay. So make sure you can tell the difference. If it's bringing people money, it's economic, huh? If it's like acting as part of an intact ecosystem, it's an ecological service, which can also be good for our economy. Okay, old growth forest. I don't think I've talked about this specifically. Old growth forest is a forest that has never been cut down. And that means the trees are several hundred years old, in some places even 1,000. Never been cut down during that entire time. Many species that live in old growth forests are highly specialized organisms. We don't have very much of our old growth forest left. Some places you could go visit old growth forest might be the redwoods in California. Tahoe is not old growth forest. Most of our trees were cut down during the mining days of Virginia City in the 1860s. So we are what we call a second growth forest. It has regrown to be an adult forest again, but it had been cut down recently. And so some of the differences would be things like in an old growth forest, there's lots of really big trees, obviously. Maybe less obviously, though, there's also a lot of trees that have fallen down to the ground where they provide habitat for creatures. There's also a lot of dead trees that are still standing that also provide habitat for creatures. Some organisms can only live in old growth forest. Now, it turns out that logging the old growth forest is often the most profitable way to go because the trees are so big, you get more lumber for less work. So logging companies often would prefer to cut down old growth forest. But look how much we have left. 1/2 to 6% of it left, still growing. One of the major locations of old growth forests is in Alaska, on that section of Alaska that reaches along the coast next to British Columbia. There's a national forest called the Tongass National Forest, and that has long been off limits to logging. I know that the timber companies have been trying to get in there. I think some of the doors for logging were opened under Trump, and I'm not sure if that's going to stay available for logging in the future or not. So we have these 3 kinds of forest: old growth, also known as primary forest, and then second growth, where it's been cut down once, but it has grown back now. And then we have tree plantations or tree farms, where we are specifically growing the trees in order to harvest them in the future. And that might take 20, it might take 50 years before they're ready to harvest. They're taking a pretty long view. And we kind of think that these tree farms in the future might supply most of the wood we need in the future, um, as long as we're managing them appropriately. The negative of the tree farm is that it's pretty much dominated by a single species. So that limits the amount of biodiversity in there in kind of a chain reaction effect. Whereas old growth has many different species of plants growing in it, allowing many different organisms to live there. Okay, so in a tree farm, this diagram is showing the tree farm. So it's going to start over here on the right where it says seedlings are planted. After 5, 10, 15 years ago have gone by, they start removing the weaker trees, or if trees are too crowded together, they'll remove one of those trees, spread them out a little bit so they're competing less. Then after 25 or 30 years, they'll cut them all down. They'll have a clear cut, which means they cut every tree in the area. It's a very efficient process, clear cutting. Makes good profits, and it works well for a tree plantation or a tree farm. Um, in a natural forest, it's more problematic. One thing that we've observed is that as we build a road to access new parts of the forest, okay, we're just going in there to get it to something. We're not going to develop the whole thing, but development usually follows. The forest gets fragmented, or it even gets deforested completely. So on the left, we kind of have the early stages of development. On the right, we have the later stages. You start by building a road in there, and that brings more people in, and then they start doing more things. And there we go. It just kind of builds on itself. Forest fragmentation means that the forest is separated into pieces instead of a continuous forest where you'd be walking in the trees for miles and miles. You walk in the trees for a mile and then you cross an open field and then you get into the trees again. And that can be problems for organisms that only live in the old growth forest because the fragments allow more invasive species to enter and they allow more predators to get in there too. So here's some satellite photos of deforestation in the Amazon showing this kind of road building phenomenon. On the left, we can see the road that got built in 1973. And in 79, all those side roads expanding on it. In 86, we're getting more and more building, less and less forest. I don't even know what it looks like now. Okay, let's talk about methods of harvesting trees. And they're giving the example of a slope here because one of the big impacts of our cutting trees down is, especially on a slope, the impact on erosion. So keep in mind, at the bottom of this hill, there is a river, there's a creek. Think about how much erosion is going to occur with each of these different approaches. So at the top, they're showing selective cutting. The, the way this works is that the first employee or a team of employees goes through the forest and they select which trees to cut down. So they're going to choose the ones to cut down based on both, is it going to be a profitable tree for us to get to, but also on the question of we need to leave some other trees alive so that they can reseed the forest in the future. But it's expensive for a couple of reasons. First of all, you got to pay that team to go choose which trees to cut down and which ones to leave behind, and they have to be trained in that. The other reason it's expensive, it's more difficult to get your equipment in and out because you're trying not to damage some of the trees. You're trying to avoid compressing the soil with the tires of your trucks. So it's much more profitable to do clear cutting as shown in the middle diagram where you just cut everything down. But as a result, you get a lot more erosion. So look at all those gullies that have formed on the hillside now, carrying sediments down to the stream. So the clear cutting not only destroys the forest right there, it also has this negative impact on any waterways that are downhill from it. Finally, we have this third option called strip cutting, where you kind of combine these two. You clear cut a strip of trees, but you leave a strip of other trees intact. And ideally, you would make sure to leave a strip of trees intact along the edges of the stream banks so that they could absorb any sediments that had been carried away from the clear cut zone. So this is relevant to us here at Tahoe too, because we want to keep the lake clear, and part of that is keeping the sediments out of the water. And so there are protected zones alongside each of the creeks that leads into Tahoe. They call them SEZs, or stream environment zones. In this class, we would call them riparian zones. And those have to be left intact. So if somebody wants to build a new house or a road, they have to avoid the stream environment zone to reduce erosion. Oh, here's just pictures of that. Selective cutting. Do you see gullies in this on this hillside? You know what I'm talking about when I say gully? It's like, see all these ditches that have eroded into the hillside here, right? Whereas we don't really see them in the selective cutting because the living roots are holding the soil intact. One way or another, we had to build a road through there. It's always a road that's going to provide access to our equipment, although sometimes they do helicopter logging, and they've done that. They've done helicopter logging here at Tahoe also. Obviously, it's very expensive. It's not very profitable. And so what they do is they cut down the trees and they bring them a short distance to an area where a helicopter can hover. Then they connect like a cable to the tree. They lift it up and they fly it somewhere that their logging truck can get to. They've done that here at Incline. I've seen them overhead, like a big tree dangling from a big helicopter is flying by, and then they're going to go drop it off where the logging truck can pick it up. But that way, they didn't have to build a road that a logging truck could get into, right? Clear cut and strip cut. Oh, and it looks like they're kind of doing a cycle here. This was cut between 3 and 10 years ago. That was cut just last year. These and this haven't been cut yet, huh? They probably won't cut the part along the stream at all. So there are pros and cons of clear cutting. You can see the photo of clear cuts in Washington State. Here's what it looks like where it's not been cut at all on the left. And on the right is where it's been clear cut. Same landscape, right? Um, and this was just probably protected as national forest. And this is probably private land that they could cut down as they wanted. And look at all the roads crisscrossing that entire landscape. There are more miles of logging road than there are miles of interstate freeway in the US. So this is, when you see this kind of a comparison, the pros and cons, advantages and disadvantages, I think these are good things to review before exams, are these diagrams that kind of quickly make a comparison of a variety of things for you. And again, maybe you could think of a test question that might say, which of the following is a disadvantage of clear cutting? So then you look through the list and you find one that would be a negative. Here's a couple pictures I took one year when I was flying to see my family in Seattle. I don't remember if this was in Washington or Oregon, but you can kind of tell if there's a landscape where there's trees going up to a meadow and the meadow is like a square, it's probably not a natural formation, right? You can also see the snow line there pretty well. And then there's all these logging roads built at taxpayer expense and accounting for more miles than all the interstate highways combined. So the Forest Service, so we did the thing about the different kinds of land uses, right? We did U.S. public lands. So if it is forest land, U.S. National Forest, then generally the forest, the, the government builds the road, and then the loggers cut down the trees and use the road to get to and from the trees. And the loggers do pay the government a certain amount of money, but I think it doesn't even cover the cost of roads, is my understanding. I think this is that same pro and con, isn't it? Yeah. Same pro and con as we looked at a minute ago. So let's move on. What happens if we deforest an area? What's so bad about that? Well, here's a variety of impacts and the degradation of natural capital that results. So, due to erosion, we have a variety of things. The soil becomes less fertile, but also that soil that's eroded away ends up in the lake or in the creek. That can be a problem for that aquatic habitat. We can have species go extinct if they're specialized to live in old growth forests. That can take them 500 or 1,000 years to be able to come back to that area. Even if a tree grows back in 25 or 30, the old growth forest takes 500 or 1,000 years to grow back. So I like to think about renewable resources as those that can be replaced in a human lifetime. So I would say a tree is a renewable resource, but a forest, an old growth forest, is not renewable because it takes too long to come back to that same kind of ecosystem. We lose habitat. We have micro changes in climate. CO2 is put into the atmosphere. We have more flooding. We have fewer recreational opportunities. So what can we do? Well, we need lumber, right? We need wood for lumber. We need wood for paper, variety of other things. I feel like this year I've used less paper than I have in a long time as a result of doing everything digitally. So I feel good about that. Although I think we kind of put a lot of electrons out of shape. So there's a bunch of things we could do, right? I'm not going to read through all of those, but of course we got to balance preserving old growth forest with protecting areas from wildfire. In some cases, the second growth forest can be more likely to burn than the old growth. For example, here at Tahoe, it mostly used to be Jeffrey pine, which we still have. A ton of Jeffrey pine has grown back, but there would not be white fir at our elevation. And we see a lot of white fir mixed in with our Jeffrey pine here. And white fir is now to the age that it's starting to die off and it's becoming a fire hazard for us. And this is because we cut down all the trees in the days of the Comstock lode, and the white fir was able to compete against the Jeffrey pine because the Jeffrey pine wasn't there anymore. So it was kind of first come, first serve at that point. But now all those white firs are dying off. A lot of them are getting infested with bark beetles. And so we're seeing an increase in fire danger as a result in our region. Okay, this is the same list of sustainable solutions when it comes to forestry. And I'm going to leave you to go through that list on your own. So the next section, how should we manage forests? What should we do? Well, there's some actions that we can take, including emphasizing ecological services, protecting old growth forests, making sure we're harvesting trees sustainably, and using substitute resources. We don't necessarily have to use wood for some of the things that we use it for. So this goes into forest fires a little bit. And well, there's healthy fires and then there's harmful fires. So the fire on the left, see how it's a ground fire or a surface fire? And the fire on the right is like a crown fire. When we have the surface fire, it's going to reduce the amount of fuel that's building up. And hopefully that's going to make sure that fewer trees get killed by that fire. It also returns minerals that were in the bushes and in the dead limbs and pine cones and things. It returns those minerals back into the soil. So you should know the difference between a surface fire and a crown fire. And I think we talked about this some the other day, right? We can reduce fire danger by having controlled burns, and we can create defensible space. We can allow small fires to go ahead and burn if they're not a threat to people. So the national forests are their description, and a lot of times you'll even see this on national forest signs or on publications. They're called the land of many uses. So the national forests we often think of as just for recreation, but they're actually the land of many uses, which means that they can also be used for logging, they can be used for mining, they can be used for raising cattle. So we have a debate about how they should best be used. Meanwhile, there's a lot of private land that is owned by these logging companies, and so they can treat it as they want. But then, of course, they're going to have to pay all the expenses involved with the road building and such. So here's the pros and cons of logging in the national forest, specifically in land with that designation. And hopefully, as you saw, Tahoe is largely surrounded by national forest, right? 3 national forests around us. What were they? The Tahoe, the Toyabe, and the other one. So the Toyabe National Forest is the one on the Nevada side. Tahoe National Forest is on the northwest, like by Tahoe City. And then the third one that I'm not remember is in the southwest. So what can we do to reduce our demand for trees? Well, we can use wood more efficiently. We can make paper out of materials that are not trees, that grow back rapidly, such as kenaf and hemp. This photo is showing this kenaf plant. Um, so basically, they look like very small trees, and you can use these to you grind them down into the fibers, and then the fibers you roll out into paper. So these are a couple alternatives. Here's another similar photo in the Amazon. On the left is 1975, same place on the right in 2001. You can see the growth of the roads and the buildings in that area. So we're zooming into tropical forests specifically now. Couple things. Did you get the different types of logging, the different methods of logging? You figured that out? What was there? Which is the worst of those methods? What's the worst logging method? Well, I mean, worst ecologically. It's the best economically, but the most harmful ecologically would be to get the timber. What was the most harmful of the 3 ways of cutting trees down? Clear cutting is the worst. Yeah. And then we had the 2 different kinds of fires. Which is the bad one? The crown fire is the bad one. Yeah. Okay, so let's look at tropical deforestation specifically. We think half of the world's plants and animals, land plants and animals, live in the tropical rainforest. And these tropical rainforests make up like less than 10% of the land on the planet, but they have half of the diversity. So very concentrated with life. But we clear large areas of them to make way for cattle ranches and for crops. So most of this loss has been since 1950, with Brazil and Indonesia leading the way on cutting down their forests. This has a big impact on extinctions because there's so many endemic species that have nowhere else to go. And I'll just go back to tropical forests for a second to point out this, this technique of agricultural method called slash and burn. So what they do if they want to raise cattle or crops in the tropical forest is they cut down the forest and they burn everything. And all the ashes that return some of those nutrients to the soil. Well, it turns out that tropical forests have very poor soil. So even after burning things and the ashes return the nutrients to the soil, they can only grow crops there for 5, 6, 7, 8 years. And they have to move on and cut down more forest. And of course, what they abandon grows back, but does it come straight back to tropical forest? Or does it go through the stages of succession and take like 500 or 1,000 years to become old growth tropical forest again? So this cycle keeps happening slash and burn, where they cut down a place, they grow crops there for a few years, but then they have to move on. Similarly, they can do that for cattle too. And I think some of the beef that they're raising makes its way into fast food burgers from Brazil. So beef grown in Brazil, you're buying at Burger King, for example. So we don't even know it, but we might be contributing to deforestation, huh? Tropical deforestation. Same thing with the palm oil that I talked about the other day, right? Okay. So then we have this other separate issue. It's also kind of a tropical issue. Um, it's a developing world issue where we have a problem where many people in less developed countries rely on wood for their energy. They need it to stay warm when it's cold. They need it to cook their food every day. And with our population growing so much, they're running out of this fuel wood. So they might have to walk a mile just to gather the sticks that they need to cook dinner that day and then walk a mile back. When I went to India, I would see people walking by with big bundles of sticks on their head, balanced on their head, that they were taking home. Um, Usually young women. This is one of the jobs the young women would have. So imagine, sorry, you're not going to go to school. You have to go collect firewood, and again tomorrow, and again tomorrow, and again tomorrow. And the more people we have gathering the firewood, the more the edges of the forest get pushed away, huh? So here's a zone where people live. There's a village in there, and they've cut down the fuel wood around them, so they have to go a little farther the next year, and a little farther the next, and farther the next year, right? And what's happening to these trees that were there? They're gone, and so the whole landscape is being deforested, and we can see desert take the place of what used to be forest. This is a big problem along the edges of the Sahara Desert. So imagine the Sahara Desert stretches almost across the entire northern part of Africa, right? And imagine the edges of the Sahara now, where it's kind of a transition zone from desert to forest. They call that the Sahel, is this place. The Sahara, and then next to it is the Sahel. Well, in the Sahel, this fuel wood crisis is expanding, and as a result, the Sahara Desert is growing bigger and bigger and bigger down into places that trees used to grow. So this is called desertification. So what are these people going to do? In Haiti, it's been an ecological disaster, but in South Korea, they've solved the problem. Well, one thing you could do is have plantations growing small trees for fuel wood quickly. Another would be to burn wood more efficiently. So instead of having an open fire, maybe you have it enclosed in more like an oven that's directing the heat to where you're cooking, not out in every direction, so you're able to make use of all that heat. Or solar or wind generated electricity. There's also something called a solar oven. I don't know if you've ever seen these or not, but basically they bake for you just using the sun. Huh? You get your food ready, you put it in there in the morning, and then all day long it gets hotter and hotter. So, you guys made those before? Yeah. Okay. Yeah. So this is an issue more in other parts of the world, huh? But it's something we have to keep in mind too. So why should we care about tropical forests? Well, they're saying the National Cancer Institute says that out of the thousands of plants that have potential cancer fighting chemicals, 2/3 of them come from the tropical forest. And here's some examples of those plants. This one, I don't know very much about this one, but apparently it provides a tranquilizer and a high blood pressure medication. This one, digitalis, is for cardiac disease. It's also a very pretty flower, actually. The Pacific yew, found in places like Washington and Oregon and British Columbia, was long considered a trash tree, kind of a small, small tree without a very big trunk and lots of lanky branches and stuff. And so when they clear cut an area, they would just burn these Pacific yews to get them out of the way. Well, it turns out that the bark had a molecule in it that was very successful in fighting ovarian cancer. So now what was once considered a trash tree is now considered a source of a medicine that's very important to people. Cinchona. Let me see. Do I remember this one? Because the bottom of it is blocked off. I don't remember what this one does. It might be an anti-malarial medication on the bark from this cinchona tree is what I'm thinking. And the specifics don't matter. It's more like the big idea is that wild plants provide us with medications. This one, medication for Hodgkin's disease. The neem tree, treatment of many diseases. That one I think is in India, yeah. And then there might be some plants that haven't even been discovered yet. Can you tell how old this is by my reference to Avatar? So what if there's some plants we don't even know what they can do yet, right? Because we haven't discovered them. So if we cut down the forest too fast, we'll not have a chance to do the research and find the cure for COVID or whatever it might be. So this is an interesting diagram because it has these two parts. All of these are causes of tropical deforestation. But we have these basic and then secondary causes. So they're saying that population growth causes deforestation. Well, it's more like population growth causes these things, and then these cause deforestation. It's kind of like indirect causes at the top, direct causes at the top and indirect causes at the bottom. Does that make sense? Because there's so many people, we have more of a demand for wood. We also have more fires. We also have more settlers that are farming because there's more people. Because of poverty, we have people that need to get things out of the forest. Because we have government policies that don't value ecological services, we have an emphasis on cash crops. So we cut down the forest, things like that. Does that make sense? How these basic services, basic causes lead to the secondary causes, and those lead to the deforestation. Okay? So think about that. Kind of like, I like direct and indirect as opposed to basic and secondary causes myself. Yeah. These ones are the direct causes. Tree plantations are directly cutting down forest, flooding from dam. But why do those happen? Because of these basic causes down here. So indirectly, these lead to deforestation. But to get there, they have to go through these ones. Huh? Okay, so here's some things that individuals and governments could do to reduce deforestation. I'll mention this debt for nature swaps. So many small tropical countries, developing countries, in order to develop further, like maybe they want to put in a sewage treatment plant or something, but that's expensive. So they have to borrow money, don't they? And so there's been a move to help encourage them to preserve some of their landscape by removing their debt from that previous work with the agreement that they're going to save nature instead. They're going to preserve their landscape, and we find value in that, so we're going to erase your debt to us. Instead of paying us back money, you're going to pay us back by not cutting down your forest. That's what debt for nature swap means. Does that make sense? Usually in a smaller developing country, that owes money to a bigger country, the bigger country can say, or the bank even can say, you know what, let's, if you show me that you're going to preserve this landscape, you won't have to pay the money back. Sounds like a pretty good deal. So, by certified lumber and wood products is the one at the bottom. So there are actually companies that will, it's like nonprofits that will certify where the logs came from. And you can even find this at places like Home Depot and Lowe's, where you can get certified wood from the like the Forest Stewardship Council, I think, FSC certified. Forest Stewardship Council will say, yes, this was cut down in a sustainable way. And so you can choose to buy that lumber instead of other lumber that isn't certified by them. Or there's some other options too, like we talked about how you can make paper out of other materials. You can also get lumber that's good for some uses, but it's not lumber. You guys ever heard of this material called Trex? Have you ever walked on a deck, a wooden deck that isn't wood? Or sat on a picnic bench that's not wood? Right? It's like built, it's actually plastic. It looks like wood, and they even will print wood grain into it, to make it look more like wood, although they wouldn't have to. But this material it is plastic, and it's often from recycled milk jugs. So your milk bottles that get recycled can be used to make this lumber substitute. And it's really good in some ways, like for a deck where it's laid flat and it's supported regularly. It's really good for that. And plus, you don't have to like stain it. If it's a wood deck, you have to paint it or stain it every year or two. The Trex, you don't have to. However, it's not so good for vertical things. Apparently, it warps when it's upright. So we don't have a good substitute for the vertical part, but for the flat part we do. So there's a job for you to invent a lumber substitute that will be good for vertical things in the future. Oh, there it is. I was just talking about the Forest Stewardship Council, right? Let's see, individuals matter. So this gal founded the Greenbelt movement. Organized poor women to plant fuel wood and protect trees. And she was awarded the Nobel Peace Prize. So good for her. All right, I want to point this out too. Once again, we see a list of things that you should kind of run through maybe before the test. Notice that some are prevention. So this is avoiding damage to the tropical forest in the first place. And this one, sometimes it says other words. This one says restoration. How do we restore it? Often it will say cleanup over here. Like if it has to do with pollution, we could have the same kind of list, prevention and cleanup. Well, it turns out that in our history, we have often focused on cleanup. We make the mess and then we have to go clean it up. Or we have to restore the forest after it's been damaged. But it's often more efficient and more economically wise to avoid the problem in the first place. In fact, I think there's a saying about that. An ounce of prevention is worth a pound of cure. Have you ever heard that before? So think about it. An ounce of prevention is worth a pound of cure. By staying physically fit a little bit every day, an ounce of prevention, you may avoid a heart attack in the future, right? That would be the pound of cure. Or here, preventing damage to the forest in the first place is a lot easier, more effective, and affordable than trying to restore it after the fact. Or a polluted river. Is it easier to clean the pollution out of the river after it's happened? Or is it easier to just avoid putting it in there in the first place? Okay, so that's it for forests. Are we good with that? Really, we broke that into two parts. We did forests in general, and then we did tropical forests, right? So we talked about logging, we talked about fire, we talked about tropical forests. Now we move on to grasslands. Um, and grasslands are pretty highly endangered ecosystems because the grasslands often have great soil. So the tropical forest has generally poor soil. The reason for that is that even though there's a lot of things growing there, it's warm and it's moist, so any leaves that fall out of the trees, they decay really quickly, and the nutrients get picked right back up into the trees again. So the nutrients don't build up in the soil in a tropical forest. But in the grasslands, the soil is great. The grasses grow every summer, the grasses grow up. Every winter they die, and in a natural grassland, that means all those nutrients go into the soil. The next year they grow again, and their nutrients are returned to the soil every year. So the Great Plains in the US is the classic grasslands that we think about, but there's only 5% of them left or something. Most of our grasslands have been converted to agriculture because the soil is so great, we're using it to grow plants that we want. So natural grasslands are largely degraded, fragmented. In other words, they're separated from other ones. And they're just small in size and small in number. So another use of our grasslands is for livestock, for grazing cattle. So they're differentiating the way we raise cattle into whether we grow the cows on natural grasslands or on grasslands that are under our control, that we manage. So rangelands versus pastures. And this even is making its way into the marketplace and into the grocery store. Like some of the meat that you see might be labeled as grain fed or grass fed, okay? Or range managed or something like this. So are they eating natural grasses or are they eating grasses that we're growing for them? It's kind of the difference between these. Now, if the plants that we're growing for the cattle could have been eaten by us, then that puts us even higher in the energy pyramid where there's less energy available. But if they're eating grasses that would have been inedible to us, then that's actually adding that energy into the pyramid for us. Does that make sense? So it seems like the range-fed or grass-fed beef ecologically is probably a better choice than grain-fed beef. Grain means you're giving it wheat or something like that that people could have eaten. And the way that we turn these cattle loose onto the landscape has an impact on the ecology, right? So if we keep a lot of them in a small area, they're going to eat the grasses way down to the nubbins, and there's going to be a lot more cattle droppings as a result too, huh? So now you have both a problem with getting rid of the waste as well as running out of your plants. And if we allow the cattle to eat the grasses down too far, that's going to cause more erosion, right? So here's an example. On the left side of the fence, cattle were allowed. On the right side, they were not. Right? See the difference? So here we have so much erosion that the plants aren't even growing back. Here are some of the ecological services of grasslands and reasons that we want to avoid allowing them to be overgrazed. Grass is kind of different than like a tree in the way it grows. So trees grow from the top. So if you cut off the top of the tree, that stops it from growing any taller. Its branches can still continue and might become new tops, but they grow from the top. Grass, on the other hand, grows from the bottom. And that's why the cattle can come along and graze the tops of the grasses off, and then that grass will grow back the next year because it grows from the bottom. So it's a little difference in their biology. Grass grows from the bottom. Yeah, that's why you can mow your lawn and it grows right back again, huh? Trees grow from the top. So this is kind of wild. Let's say you have a 10-year-old tree and it's got a branch right at the height of my eyes. If I come back in 50 years, how high will that branch be? It will be the height of my eyes. But will there be new branches higher than it? Yeah, because it grows from the top and forms new branches, but where those branches form they stay in the same place. The trunk stays in the same place. It gets taller and taller, and it gets wider and wider, but it doesn't have the bottom of the trunk moving up like an elevator. That does not happen in trees, but it does happen in grass. Like if you zoomed in, you could see the grass is actually getting longer and longer from the bottom up. Right, if you cut the top of the grass off, it just keeps growing back. But if you cut the top of the tree off, it doesn't grow up there anymore. It has to grow out to the side. Okay, so what happens when we overgraze the rangelands? We get less grass, we get erosion, we get compaction of the soil. Think about it. How heavy is a cow? And they're walking around, and if they're in the same area too much, they compress the soil down so much that it doesn't have the air spaces and the water spaces. This can be an advantage to invasive species, and sometimes those cattle won't eat those invasive species. So they grow, their population grows even more. So what can we do? We can first of all do rotational grazing. So let's say for May, you have your cattle over here. And in June, you move them to a different area. In July, you move them to another area. And you rotate back around so you're over here again in May. Does that make sense? So you're not impacting that same zone all year long. You can also suppress the growth of invasive species, but sometimes it's really hard to get ahead of that. If they get their roots in the soil, it can be really difficult. We have a problem with a plant called white top, tall white top. We have a problem with this plant here, and it's really difficult. You practically have to dig it up by the roots to get it out. Here's a couple other options: replant barren areas, apply fertilizer, reduce soil erosion. Maybe you would like put some barriers to the movement of the soil in so it didn't get carried downhill. Okay, that was it for grasslands. I want to say one other thing that I thought would come up and didn't, and that is that cattle have a tendency, like if there's a creek in the area where they have a tendency to hang around the creek. So imagine, I don't know, a dozen cows at this creek, and they're walking around in the water on the banks. How much erosion do they create? They're pooping in the water. They don't really care. They just let it go, right? So what is the impact on the cow on the creek if we allow the cattle down into the water like that? It's pretty negative. And this is different than like bison, buffalo, which are they will go to the creek for a drink and then they leave. Because as I mentioned earlier, oftentimes there's all the growth on the side of the stream. That's a good place for predators to hide. And so bison still have that behavior to avoid staying at the creek where there could be a predator. But the cattle, that's kind of been bred out of them. That wariness is no longer there. So they just mill around and they harm the creek bed as well as the grasslands. Okay, next topic, parks and nature preserves. So one of the actions we can take to sustain biodiversity is to protect more areas as parks and nature reserves. And this is true both on land and in the water. Countries have established more than 1,000 national parks, but most are threatened. Um, People go into the park to get wood, to grow crops. Loggers and miners and poachers go in there. Some of the parks are too small to really sustain large animals in a population level. And then we have problems with invasive species as well. In the US, one of the problems our national parks have is that people are loving them to death. So just overuse, like Yosemite National Park in California, beautiful place, almost impossible to get a campground reservation there now. You have to be like on the website at midnight on January 1st to get your campsite there for August. And then it's pretty crowded when you're, in the main areas. If you go hiking in the backcountry, go backpacking, then you can get away from people. And I'm not saying don't go to Yosemite. It's a fantastic place. You should go there. It's beautiful. But we are kind of loving it to death. And as we've noticed here at Tahoe, as people come up to the lake in larger numbers than they have before, and some of these people have never really been in the forest, they might not know how to behave in a sustainable way. So we're seeing a huge growth in litter around the lake. We talked about that a little bit with those guys from Turk, huh? So the greatest biodiversity, of course, is in the developing countries because they're often the tropical countries where we have tropical forests that have more biodiversity, right? But only 1% of them are protected against poaching, logging, and mining. One of the problems is that poaching can be so profitable that the poachers can have weapons that are better than the rangers. Like you hear about in Africa, where they're trying to protect, the rangers are trying to protect the rhino or the elephant. And the rangers might have some kind of like some kind of old rifle, and the poachers have machine guns. So it's pretty dangerous to be a ranger in those areas. In the US, we have 58 major national parks. Yosemite is one of them. The biggest problem might be their popularity. And this was written like 10 years ago before COVID hit. And I feel like one of the reasons we've seen so many people coming up here since COVID is because people can't like fly to Europe, right? So their more distant vacations that they would have done got canceled, so they drove to Tahoe instead. So we're seeing all this popularity, noise, congestion, pollution, damage and destruction to vegetation, wildlife, people like tagging, for instance. And that's been a problem here at Tahoe too, both with paint and with carving things. And then, of course, we have to maintain the trails. We have to maintain the buildings. We have to clean the bathrooms. All those kinds of things take money. So what do we do? Well, there's a bunch of things we could do, right? Sometimes when a park was established, there was like somebody owned some land right here, and the park was established around it. So there's like this little island of private land in the center of the park. And that private land can mean they can do what they want with it. It can mean they have to be allowed access to it. So maybe that land should be bought and become part of the park But who's going to pay for that? The taxpayer, right? And that means that our representatives have to promote that idea. Limit the number of visitors. So it's getting to the point where you have to get reservations to go to some of these parks. And even in some of them, because of the congestion of traffic and because of the smog from the traffic, they might not let you bring your car in there anymore. So I think Yosemite is partly this way. They're trying to get people to park their cars outside of the park, and then they have buses that bring people in, for example. And if you're camping there, you'd have to bring all your gear in with you too, huh? Which might be tricky. And you'll notice that a lot of these have to do with money, don't they? One of the problems, okay, so we raise the entry fee, right? So we can pay for it, but is that fair to everybody? It's not a problem if you've got a good income, right? But shouldn't anybody be able to go to Yosemite regardless of what their income is? So if it costs, I don't know, 25 bucks a person a day, there's some families that they're not going to afford that, huh? And so they're not going to go, and they're never going to have that experience. It's an incredible place. Okay, nature reserves, similar to the idea of a park, but usually the national park. Oh, and I will say the U.S. is the first one to ever have a national park. The first park was Yellowstone, established by Teddy Roosevelt. So sometimes that's called America's greatest idea. Looks like you guys have been studying that in another class too. Yeah. Yeah. So, yeah, Teddy Roosevelt, he had a lot of great ideas about preserving landscapes and about how healthy it is for us both physically and mentally to get out in the landscape. He was a hunter and a fisher, so that's part of his view. Um, I'm not either, but I like adventure outdoors, climbing a mountain or rafting down a river or whatever. Those are fun for me. Um, but let's see, John Muir. You guys know who John Muir was? Okay, so John Muir was born in Scotland, raised in Wisconsin, and then when he got, I think Wisconsin, one of those states over there, when he was old enough, he walked to Florida. So imagine Wisconsin to Florida. Yeah, this is in the 1800s, so people were more used to doing that. And then he came to California, and he totally fell in love with Yosemite. And he'd climb the mountains, and he would do crazy stuff and write these essays that were then published in the newspapers or across the country. So he's very famous for that. But he'd do crazy stuff like, oh, there's a giant windstorm. I'm going to climb that 100-foot tall tree and see what it's like to get blown around in the wind. He did this crazy stuff. So he and Teddy Roosevelt actually went camping together at Yosemite at one point. Like John Muir was his guide. So, and he established the Sierra Club. He was the founder of the Sierra Club. Um, at any rate, a nature reserve is less about people using it than it is about preserving nature for its own sake, for wildlife, etc. Okay, so we can see there's pros and cons. 12% of Earth's land area is protected in nature reserves, but only 5% is strictly protected from harmful human activities. Conservation biologists think we need 20% protected to maintain our biodiversity and to represent all of our biomes. So we can have large or small reserves, but keep in mind that for like a population of predators, predators are way up at the top of the energy pyramid, huh? So they need a big population of prey to sustain them, and that big population of prey is going to need a large area to sustain them. So if we want to preserve tigers, for instance, in a viable breeding population, we need really big nature areas. Here's another idea, the buffer zone concept. Here's your core natural area where it's totally protected, and then that is surrounded by a buffer zone where you allow some activities, and then outside of that, you could allow any activities. And then another important idea is the habitat corridor that would connect these nature preserves. So maybe we have a population of tigers over here, and there's a population of tigers over here, 10 miles away. Is there a way for the tigers to get back and forth to visit each other when it's mating season? Or is it crisscrossed with freeways? Which is kind of an interesting question here. You know, we have this, we have a large predator in our zone, right? In fact, I saw bear footprints this morning. And so how do they get around without getting hit by a car? Or do they get hit by cars? You see the signs, right? Yeah, well, it happens. Yeah. This is Costa Rica. Look how much of their land is protected. They're trying to sustain 80% of their biodiversity. So they've named these 8 regions, I guess, and then within each region we have a number of nature reserves, and often they're connected with habitat corridors. So Costa Rica is kind of leading the way worldwide in terms of protecting landscapes. The Wilderness Acts. Okay, so I do have an assignment for you where you're going to read more about wilderness. So wilderness is a special designation of a landscape where basically it has to be left alone. You can't mine there. You can't cut trees down there. You can't even have a mountain bike there. You can't have anything mechanized there. It's a place where people are only visitors. It's supposed to remain unchanged. No roads can be built. You can do anything you want on foot, including skis and snowboards. Usually horses are okay too, but no snowmobiles, no motorcycles, no ATVs or trucks, no mining, no logging, no grazing cattle. And this could be part of a national forest. It could be part of a national park. It could be part of BLM land. So it might be organized by any of those groups or administered by any of those groups, but it's the most highly protected type of land in the U.S. It's wilderness. And the closest wilderness to us, we could be there if we were driving. We could be there we could park in about 10 minutes, and in about 15 minutes of walking, we'd be in the Mount Rose Wilderness. So, what do we got here? I think this is kind of a summary section at the end, and some of the actions that we can take to protect these areas. So what is this ecosystem approach? Well, we dominate most of the land and the sea at this point, so will we make a choice to share it with other organisms? Should we? Do we need to? This should have been earlier, but here's the idea of this biosphere reserve with a core area that's totally untouched. Maybe you can walk in there like a wilderness area. Then around it is a buffer zone, and here they have 2 buffer zones with different things going on in each zone. So only the research station is in the first buffer zone. We have a tourism and education center in the second buffer zone. The human settlements are outside the buffer zones. However, there might be a couple that were built 100 years ago, and we can't exactly kick them out. So that would be one way to design a biosphere reserve. 4-point strategy to protecting ecosystems. Notice the first one, really the first 2, are about finding what's there. and then basing our protections on what we learn from making more accurate maps, on identifying what's there, locating which ones are endangered. And then we can take action. We have to get information before we can take action, though, huh? Another idea is that we focus on protecting what they call global hotspots, these prime areas of biodiversity, a biodiversity hotspot. So these are 34 biodiversity hotspots across the globe where we have high levels of endemic species and unique species. You can see California is a major one. Most of Central America, of course, the Amazon and the Andes Mountains, and we could go on and on naming these places. The more unique it is, the more likely that it's been suggested to be protected, like the entire island of Madagascar, down here by Africa. The only place where there's lemurs. But there's like 30 or 40 kinds of lemurs. Let's see. Okay, we talked about wilderness. Okay, this is what I was driving for. Here we have the 1, 2, 3, 4 R's for restoring ecosystems. Restore it, rehabilitate it, replace it, and artificial ecosystems. That's the 4th R, artificial. So restoration is after it's been damaged, trying to get it back. Rehabilitation, also trying to get it back, usually not bringing it completely back. Replacing it, okay, it's too late, we can't bring it back, but we can put another ecosystem there. Maybe we can have a nice grassland where there used to be a forest instead of just an eroded hillside. And then artificial ecosystems are also possibilities where we are totally just building an ecosystem there to meet our needs. So these are methods of restoration that I refer to as the 4 R's. Well, if we're able to fix things, then might we just keep damaging more things because we know we can fix them? So remember, preventing the damage in the first place is cheaper and more effective than trying to fix it after the fact. Okay, win-win ecology, what can we do? 8 priorities. I'm just going to let you read through these, I think. What can you do? There's some things you can do. I think all of these lists of what you can do at the bottom should say vote. And that's the end. All right. So if we look on Teams, let's just check. Let's look in the files. So I'm going to the files section. I'm going here, Unit 5, Sustaining Biodiversity. And then here's these 3 PowerPoints. All right. This is the one we just did, or a very similar one. And then we have lists of objectives, outlines for each chapter, vocabulary lists, and summaries of each chapter. So I've got all these materials for you in the files section that you can refer to, and I'll leave them there until we're done, because you might want to refer to them as part of getting ready for the exam in the future.